friends, and welcome back. So, we have looked so far at the first step of the 5 steps involved in non-motorized transportation planning. So, in this lecture we will begin with working on the second step, which is planning and designing of NMT systems. This planning and designing of NMT systems, and within that we will be looking at how to develop detailed road inventory, how to conduct surveys in order to determine the demand for NMT systems, and how to measure the existing level of congestion along the roads that will determine the need for non-motorized transportation, existing levels of motorized congestion on existing roads. Okay. So, the first step in planning and designing is to develop detailed map of existing infrastructure and also developing the demand estimate for NMT, right. We have looked at how to map existing infrastructure already based on different types of data that may be available in your CDPs and CMPs. Now, using that data, we have to determine the demand for non-motorized transportation. The demand for non-motorized transportation meaning how many people would want to choose the different types of non-motorized modes for their different trips that they make during the day or night, right. So, you have options to choose different types of modes in your city, right. You can go from point A to point B either using your car, your two-wheeler, public transportation modes, intermediate public transportation modes such as auto rickshaws, or also some non-motorized modes such as bicycle, walking. Some cities also have cycle rickshaws. So, these are but you have to know how many people, or you have to have an estimate of how many people would want to probably use these non-motorized modes. So, in order to know that, you have to determine the demands for that, and more or less people do conduct primary surveys in order to estimate that demand. Along with estimating the demand, you also have to have detailed maps of the infrastructure that is available in your cities, right. They can be obtained from different types of, again, primary surveys or existing government reports. Satellite imagery is becoming much more widely used in India currently, right, with our growing accuracy or growing information that is available from ISRO's satellites. We are able to more clearly see what is the urban infrastructure that is available, right. As the resolution becomes more and more smaller and more pointed, we are able to even just look at a Google Earth image to understand how wide a road is, or how wide a sidewalk is, and for what distance the sidewalk is present along a road. So, we can get a lot of data from satellite images currently. And for understanding the different levels of traffic congestion, we usually do spot speed studies or delay survey studies. This is essential to understand because once the congestion on the road grows, it is usually an indicator that a non-motorized transportation use is less, or there is a latent demand for non-motorized transportation, maybe because we are already oversaturated by congestion, oversaturated by motorized modes. Hence, non-motorized modes has to be brought in to the system. So, that is a kind of indication of when do we need non-motorized modes. So, this is an example from of different maps that can be produced using satellite imagery. This is available at the Bhuvan portal. So, you would see that you can identify what are the roads that are available in your area. You can understand the land use that is available. So, the land use is in different colors here, the orange color, the different purple colors, small yellow colors. So, that gives you the different land uses, and also you can understand what kind of a terrain you are in. So, all of these are now very readily available from the different portals that are usually handled by ISRO or some other agencies like that. Next, in order to understand how to develop demand estimation for non-motorized transport, usually 4 steps are carried out. You have to conduct a survey. This is a primary survey, a questionnaire survey that people usually conduct on a sample of your population that is in the city, right. You cannot go and ask every person in your city about an opinion, that would take a long time and would be unnecessary also. How to determine the sampling, what are the different sampling techniques, we will be letting you know shortly, and using that data that you collect in the survey, you then have to develop answers to these questions as to what are the basic origins and destinations between which people are likely to use non-motorized modes of transport, which non-motorized mode of transport are they likely to use, are they likely to walk, or are they likely to use bicycles, what are the trip distances that can be obtained from the origin destination maps, and for what different trip purposes are they going to use it, right. Are they going to use it to go to work, or are they going to use it for leisure purposes, are they going to use it for exercise, daily chores, or what are the different purposes. So, a questionnaire survey usually is used on a sample population of your city. It may not be, if it is, so remember that there are different scales of having non-motorized transportation projects. So, if the scale of the project is city, then you have to develop a sample for the entire city. If the scale of the project is just a street, then all you have to find out is how many people live alongside that street, and you have to sample only a few people along that street. Okay. So, here is an example of a survey questionnaire that is usually used. Again, all of this is available in the guidance document from which all of the material has been taken. The survey questionnaire has different types of questions, questions about the demographics of the area, questions about which mode did you use for this particular, for different trips, when do you, if you use a particular mode, what is the travel time that it took on that mode. So, these are various quantitative levels that are asked. At the same time, there are different qualitative questions that are asked, such as what is the quality of walking facilities. So, do you think it is excellent, very good, good, bad, or very bad. So, this is a 5-point scale. It is usually called a 5-point Likert scale, right. These are the type of questions that are asked usually in a questionnaire that is used to determine the demand for non-motorized transportation modes. They are both qualitative and quantitative in nature. That is the essential part to remember. If it is highly qualitative in nature, then it is difficult to infer what type of facility and where those facilities would be needed. And if it is purely quantitative in nature, then you do not understand the perception of the people as well who are going to use it. So, it is very important to merge both qualitative and quantitative questions. How do you determine? So, what do we mean when we say sampling, right? These are a sample from a population is always statistically a significant sample size, right. So, if you use statistical formulas, that will tell you that if your population size is n, you may have to only collect 0.01% of n in order to be having a sample size that is representative of your entire population. So, the idea is to sample or ask n number of people in your city or in your area who are representative of your entire city or area. You cannot go ahead, if your city's population is 1 million, you cannot go ahead and ask all the 1 million people about what type of transportation do you want to use, do you like the quality of the NMT infrastructure available. So, you would only ask a few selected samples, and that is what we are telling to we are trying to explain how to develop a sample from a population. Usually the terminologies used in sampling are confidence levels, margin of error and standard. So, usually the confidence level used is 95% and the margin of error is 5%. So, what that essentially means is that every time if the same sampling is done n number of times from the same population, then 90.95 times n of the cases will have result which is within plus or minus 5 of your answer, right. If the average will be plus or minus 5 within the answer. So, for example, if the population size is 1000 and if you want to know whether and if you have collected data for 200 samples only, how satisfied are you, and the question asked was how satisfied are you with the NMT facility on a scale of 1 to 10. So, you asked this question to 200 people, however, your total population was 1000 and the answer came out to be, the mean satisfaction score came out to be on a scale of 1 to 10, it came out to be 8.06. Now, if the same 200 samples were drawn 20 times from the same population, okay, different samples, maybe they are different, maybe they are same, but they are drawn 20 times, then what this 95% and 5% says that it means that 95% of 20, which is 18.05 or say approximately 19 times. So, out of 20 times 19 times the result would be within plus or minus 5%, this is 5% plus or minus 5% of your mean value. So, the answer will be between 8.01 and this should not be 9.11, this should be this is 9.1. Okay. So, the answer will lie between. So, you are confident that the answer is 19 out of the 20 times the answer is between these two. So, since we are using, so what this tells you is that we are using probabilistic ways. So, estimate, whenever we are saying that you have to develop an estimate, estimate means a probability, it is not deterministic. Deterministic means we are determining exact number who is likely to use non-motorized transportation. Exact numbers are difficult to determine because of the population size and the variability in the population. Hence, we develop estimates and it is imperative that the estimates are close enough to reality. So, they have to be calibrated and validated, so that they can be then used in order to develop or implement these NMT systems. So, then there are statistical formulas that will tell you how to develop the sample size. So, if you go back to this example, in order to know what this, how we arrive at 200 for a population of 1000, this is an example of a formula that can be used. You can easily follow the formula and say this is an example problem that we have shown in a city that has a population of 15 million, there are 8 million males and over 6.5 million females. The objective, there was a survey conducted to understand the feeling of safety and security among female bicyclists, right. So, the objective was to find safety and security amongst female bicyclists. So, if you have 6.5 million or more females, then you want to know what is the sample size or how many females should be contacted for the survey, so that we have a result that is representative of the entire population, or in this case the population is 6.5 million. So, if you go ahead and use this formula, here is the population size n, and if you use the formula you would get that the answer is 385 females. So, you see, out of a population of more than 6.5 million females, if you just sample 385 females, you would get an idea, a fair representation of what all the females in your city or area want or feel about the safety of bicycling. So, that is an example of how you find out a sample size. There are different calculators that are available that you can just put in the population size and they will give you the sample size. They usually use this formula or any variant of this formula to determine the sample size. Now, what should be your sampling strategy, right? Now, we found out in this previous example that we wanted to know about female bicyclist safety and security. So, your sampling strategy should also be dependent upon who you are trying to ask the question to, right. There are different types of sampling strategies. So, if this is your entire population, you can either do a simple random sampling, you can just pick any number of marbles from there, right, that is simply random sampling. You can do some systematic sampling. So, you can do 1 red, 2 green, 1 blue, some kind of a systematic sampling. You can do different stratified sampling. So, you can say that I will take 3 red, 3 green, so on and so forth, and then you can do some cluster sampling. So, the cluster samplings are if you have certain criterias by which you can break up this population into different clusters. So, there are 3 different criterias used here, and that will tell you how many samples you need from each cluster. So, for example, census sample surveys. So, if you ask this question in a census is a simple random sampling. Okay. So, when we do census every 10 years, it is a simple random sampling. Whereas, say if you want to do a systematic sampling, what is systematic sampling here? You want to sample houses on a street with odd house number, right? Every house has a number. So, you only want to sample on a in the houses that have odd house numbers. So, that is a system. The system is odd house number. So, you are doing a systematic sampling. Stratified sampling, again sampling for genders, right. So, if you only want to do female, so that is a strata or a layer. Then cluster sampling, sampling from residents of every collector street in the city. So, that is a criteria. The criteria is collector roads. So, if you want to create all the residents who live along collector roads, that is a type of road. So, that becomes a criteria and you use different clusters. So, that is an example of different types of sampling strategies. Now, remember the third step or the second step we wanted to know was what is the level of traffic congestion on the existing roads. Unless you know the level of traffic congestion, meaning motorized traffic, you would not understand the need for non-motorized transport, and only then you can understand the demand for non-motorized transport, right. So, traffic congestion usually is measured by what is the different types of speeds on your roads, right. If you say the speeds are low, that means it is usually an indication that there is a lot of congestion, travel time is low, speed is low. So, here we are telling about speed. So, usually what we do is something called spot speed studies. So, we record the speeds of a sample of vehicles at a specified location at different times of day, right. If you do that, then you would know different times of day what is the congestion level by measuring the average speeds, and that will give you an idea of how congested that road is, and that will in turn tell you maybe there is a need for decongesting or having more non-motorized facilities on that road, right. So, the technique used is called a moving vehicle technique in order to understand what is the average speed. Moving vehicle technique is nothing but you drive a vehicle, your test vehicle in along the direction and also in the reverse direction, going at a speed that is more very representative of the traffic stream. So, you do not drive very fast or do not drive very slow, and how do you know whether you are driving too fast or too slow? While driving the car, you have to make sure that you overtake the same number of cars as are overtaking you, right. If you overtake 2 cars and 2 cars are overtaking you, so that means you are kind of driving at an average speed of that traffic stream. So, it is a very simple experiment. You just take your vehicle, make different number of runs between two origins and destination pair. So, in that you will be able to understand what is the average travel time or average travel time on that segment. So, that is given here using these these two formulas. You first have to understand what is the volume in that direction, that is V E, and then you will know what is the average time taken in that direction to travel, right. So, and then you can do this at different types of roads also. You can do it at a road which is usually called an uninterrupted urban corridor. Uninterrupted urban corridor meaning there are no intersections along that road for almost about 1.5 to 3 kilometers. Interrupted urban corridor meaning there is a controlled intersection, that means there is a signalized intersection for every 1 to 1.5 kilometers, whereas an interrupted interurban corridor meaning along 3 kilometer stretch there are several number of service roads, access roads, so on and so forth. So, these all are available in the newly available INDO-HCM, Indo Highway Capacity Manual. These different classifications of roads are available, and you could do a travel times, travel speed, travel time, travel speed study on these types of different types of roads. In order to remember, we are trying to get an estimate of the congestion along those streets. Congestion usually meaning motorized congestion, and that in turn tells you the need for NMT, non-motorized. Okay. So, these are now what Indo-HCM goes ahead and develops develops a scale for different types of travel times, right. This is travel time essentially in seconds per kilometer. So, every kilometer what is the travel time along these three different types of roads, and these are broken up into all these different scales. So, if your travel time along your particular type of street is anywhere between 135 to 186 seconds every kilometer, then this type of road, then you have an interrupted corridor with a level of service C. So, what that level of service C meaning the congestion is at average level, level of service A meaning your travel speeds are pretty good. So, the congestion there is non-existent congestion, there is no congestion, whereas level of service E would mean there is heavy congestion on your streets. So, here is an example problem. Determine the level of service of a private vehicle plying on an interrupted urban corridor, right. So, that is the type of corridor of length 2 kilometers using the moving vehicle travel time data. Determine the level of service only in the east direction of movement, and the volume is, in this case we have made it simpler, we have already given you the volume. So, here is an example on in the east direction we have run our test car 6 different times. In 6 different times we have had 6 different travel times on that corridor, and every time we have identified the number of vehicles in the opposing lane, the vehicles overtaking the test vehicle and the vehicles passing the test vehicle, right. In this case you would see that the driver may not have driven well, whereas here he might have driven very well because 12 and 13 are very close to each other. Here definitely not, here definitely not. So, that kind of averages out how you drive your vehicle. All you have to do is you have to develop an average of each of these, right, and then using the formula that was given to you earlier, you put it in the formula to determine the average travel time each of this, and you get the average travel time as 4.74 minutes or 284 seconds. Now, that 284 seconds was for 2 kilometer. So, for every kilometer it is a 142 seconds. Now, if you go back to your table and you see where 142 falls, since it is an interrupted corridor and 142 falls here. So, your level of service is of moderate congestion C, level of service is C. So, that is how you determine what is the level of congestion along different corridors in your road, in your roadway network or in your city or in your area, and that in turn tells you the need for non-motorized transportation. If the level of service becomes very poor for motorized conditions, then you will have to develop non-motorized transportation. Again, these are the references that are available to you. Most of it was taken from the NMT guidance document, but the example problems were also taken from Indo-HCM as well as a textbook on traffic and highway engineering by Garber and Hoel. So, I hope you have followed through in this presentation, where we have looked at the second stage or the second step in the 5-step planning process, where we have looked at planning and design of NMT facilities. We have given you how to determine the demand using using conducting surveys, and in the surveys how do you determine sample size, what is the sampling strategy that should be used, how do you analyze different types of data, socioeconomic, travel mode, distance, and then how do you understand the level of congestion using average travel speed formulas, and how do you conduct that study. Thank you.